So we haven't been getting too much information on Neptune for some reason. I don't know. It's kind of like it's trying to fly up under the radar, but no more. Nah. We going digging for the information today. So we're going to check out this video from the Voyager channel. Shout outs to them. Make sure you go subscribe to them. This one is NASA reveals Neptune is not what we're being told. All right. So we're going to get into this video. If you knew, you know what to do. Hit that subscribe button and join the family. Let's check this out.
Scientists were shocked to find out that strange and unexpected things are happening on Neptune. Neptune is the keeper of the deep, the last known major planet from the Sun, the god of boundless sea beyond the inner solar system that marks the shore of the black depths of interstellar space. Neptune wasn't discovered until 1846, despite having a diameter 4 times that of Earth and being 4.5 billion kilometers away from us, making it appear small and dim, even to powerful telescopes.
Yeah, we got to get our weight up. Earth got to get its weight up, man. These other planets are just swallowing us comparison to size, bro.
Throughout the past 2 decades, scientists have seen dramatic changes in the planet's atmosphere, and its most recent changes have scientists worried. What's happening on Neptune, and how can this have a detrimental effect on our everyday lives? Let's find out. Neptune isn't something you hear much about, is it?
No.
Certainly not as frequently as the other planets. Images of Jupiter's clouds and Mars's surface are frequently provided by space robots. Mercury is frequently blamed for astrology enthusiasts' terrible days, even though Mercury being in retrograde is actually just an optical illusion in our night sky. The Cassini spacecraft orbited Saturn for 13 whole years before crashing into the planet, ending its illustrious run of observations. Additionally, planetary scientists have said that NASA ought to give top priority to sending a probe to Uranus in the upcoming 10 years. In fact, Neptune's brief presence in the headlines, due to a new study regarding what makes Neptune so blue, was unusual. Even that discovery, according to Patrick Irwin, the study's lead author and a planetary physicist at Oxford University, was unintentional. Irwin claimed that his team's goal was to research the atmospheres of Neptune and Uranus rather than to look into the specific enigma of Neptune's beautiful appearance. This is how the 2 ice giants, so named because researchers think the planets were initially glommed together from icy materials, are frequently investigated. They are roughly the same size, bigger than Earth but smaller than Jupiter and Saturn, and share a lot of other characteristics. They are planets without surfaces that have atmospheres made of hydrogen, helium, and a small amount of methane. Scientists believe that under extreme pressure deep inside these objects, diamonds are being formed when carbon atoms are compressed. Scientists previously knew that the methane in Neptune's and Uranus's atmospheres, which absorbs the red colors of incoming sunlight and leaves blues and greens for our eyes to view, gives them their generally bluish appearance. Irwin and his associates discovered that a certain layer of methane haze on Uranus is twice as thick as it is on Neptune, though. If there were no haze, Irwin claimed, these atmospheres would be naturally blue. They get paler when haze is added. The scientists hypothesized that Neptune's atmosphere, which is more turbulent, is better suited to stirring up methane particles and thinning out this layer. Because of this, Neptune is the bluest planet in our solar system, while Uranus is a gentle aquamarine, making them the ideal contrast for our most underappreciated planet. Neptune should, in theory, be able to enjoy its position in the cosmic lineup as the planet that is furthest from the Sun. But everyone is still debating whether Pluto counts as a full-fledged planet or not, despite losing its position in the final position in 2006.
We were told it's not. They were considering Pluto, a dwarf planet? They didn't consider it a full planet. Yes, hurt my heart too, especially after all we had been told growing up. You know what I'm saying? That Pluto was always included. Nope, just found out recently it's not.
When planetary scientists aren't arguing over that, they're looking for Planet 9, an imaginary planet that is said to orbit the Sun beyond Neptune and whose existence could be able to explain the odd orbits of some distant celestial planets. If NASA follows the advice of the scientific community and sends a spacecraft to Uranus in the coming years, Neptune will be the only planet that humans have yet to visit on a special mission. It wasn't until astronomers noted that Uranus, which had been discovered by telescope in 1781, was being pulled about in its orbit by the gravity of an unknown celestial body, that they recognized it was there. Finally discovered in 1846, Neptune was found exactly where scientists had expected. NASA's Voyager 2 spacecraft arrived in 1989, many years and technological advancements later, zooming past Neptune and the last stop on a grand tour of the outer planets. We got a close-up view of a gorgeously blue globe, its moons and its rings during the flyby. Undoubtedly, Neptune has rings. Although not as beautiful as Saturn's, they do exist and were created from tiny rock and dust fragments. Since then, no spacecraft has landed on Neptune. Because Uranus is closer and would be easier for our space robots to reach, planetary scientists recently recommended choosing one ice giant over the other to NASA. Exploring planets that take so long to orbit the Sun, 84 years for Uranus and an incredible 165 years for Neptune, presents such a challenge. Undoubtedly, a focused mission to Uranus that landed in the early 2030s would increase our knowledge of both ice giants. That, however, does not truly give Neptune its due. The final planet in the solar system has a unique history and peculiarities that are fascinating and enigmatic in and of themselves and deserving of our focused attention. A series of Hubble Space Telescope observations of the giant planet Neptune reveals that a massive dark storm raging in its northern hemisphere was moving south when it suddenly made a sharp U-turn and started moving back north. In addition, it might have given birth to a young dark storm in the process. The term ice giant refers to Neptune, which is essentially a huge ball of hydrogen and helium gas that also contains a lot of methane, ammonia, and other molecules. For historical reasons, planetary scientists still refer to these molecules as ices, even though they are gaseous. Neptune is the largest planet that is the furthest from the Sun, at a distance of 4.5 billion kilometers, approximately 4 times the diameter of Earth. Scientists were shocked by the images Voyager 2 returned after passing by Neptune in 1989. It revealed a massive oval dark storm the size of Earth in the planet's southern hemisphere. The Great Dark...
Even the storm is the size of Earth, man. Yo. And like I said the other day, man, that makes me think about us, bro. I just feel like it's coming. It's coming. Soon, we're going to have these size spots or similar. You know what I mean? We probably won't have them on the sides of our planet because these are the size of our planet, but we may have a continuous storm at some point in time in our lives, or either the next generation, they may see it and it may form and never go away. Wouldn't that be crazy?
Storm the size of Earth in the planet's southern hemisphere. The Great Dark Spot, so named because it had the fastest wind ever recorded in the solar system, has wind speeds of a staggering 2,100 kilometers per hour. But the spot was gone when Hubble observed Neptune in 1994. Poof, disappeared. There is no doubt that Neptune storms develop over shorter periods than those on Jupiter, where the Great Red Spot has endured for centuries at least. For instance, a small dark patch in Neptune's southern hemisphere was discovered in the same 1994 Hubble observations. This dark spot must have formed between Voyager flyby and the Hubble photos. Since then, Hubble has discovered several more black spots. They develop at mid-latitudes in both hemispheres and tend to move in the direction of the equator, but they face certain death if they do that. As a result of the Coriolis effect, which states that the speed of a planet's rotation varies with latitude, with a maximum at the equator and a minimum at the poles, air flowing outward from a large high-pressure system or inward toward a low-pressure one will cause the system to begin rotating as it meets air moving at different speeds to the north and south. As these Neptunian storms move in that direction, the Coriolis influence weakens closer to the equator, which causes them to fragment. The majority of these storms appear to end up there. Not this time though. In September 2018, Hubble observed a mysterious storm in Neptune's northern hemisphere. The entire continental United States could easily fit inside this enormous, over 7,000 kilometer wide object, which was seen to be traveling south. However, inspections made in January 2020 revealed that the storm's southern movement had been reversed and was now once more headed north. Neptune is a mystery to scientists who study it. But there's more. This storm has been linked to two further strange occurrences. One is that it seemed to have created a smaller dark storm at the time it changed its mind and began moving north again. This is predicted to occur by some computer simulations of Neptune's atmosphere, particularly as a large storm begins to dissipate towards the equator, when it can drop smaller vortices. Although it wasn't directly observed since the observation was spaced too far apart, it's possible that this is what happened in this instance. It may have shifted course due to that, according to certain theories. Strangely, unlike almost every other dark storm, this one doesn't have bright white clouds circling its edges. These methane ice crystal clouds are highly reflective and appear white in photographs. Winds carry methane gas up the slopes of the dark storm's high-pressure system, which resembles a mound of air in the atmosphere. Here, the methane cools and crystallizes into ice. Orographic clouds, which occur when water-rich air pushes up the side of a mountain, cools, and condenses to create clouds, are typical on Earth. Images from 2019 showed the Neptunian white clouds, but they vanished at the beginning of this year. The strange behavior of the black storm might be related to this, or maybe not. Due to its distance, Neptune is challenging to observe and comprehend, and despite its enormous size, it still appears very small in our telescopes. Additionally, it is challenging to understand what's happening there due to the atmosphere's rapid changes.
So if the temperature don't get you, the storm will, the huge storm will.
Neptune also has Triton, a planet-sized world with a smooth, icy surface which it stole from a nearby region millions of years ago. Triton is one of the most fascinating moons in the solar system. As was previously mentioned, Voyager 2 sent back its sole close-up image to us in 1989. But this year, JWST focused on the far-off planet, sending back some of the best images of its moons and rings that we've seen in the past 30 years. Methane, ammonia, and water are among the several chemicals found inside Neptune. However, because methane also absorbs infrared light, Neptune appears relatively faint in JWST images. Methane is very good at absorbing red light, giving the planet an eyepiece appearance of a rich blue. It does, however, have methane ice clouds at high altitudes which, in contrast to the gaseous form, are highly reflective and appear bright. Similar to storms on Jupiter, they appear at various latitudes above the deeper cloud deck. Neptune has several rings just like the other three giant planets. These rings are probably made of ice particles that have been covered in different molecules that give them a reddish appearance. This makes them brighter in infrared wavelengths and makes them visible in the JWST image.
I mean, that far away from the sun, I wouldn't doubt it. The rings are made of ice. I wouldn't doubt it. Ice, rocks, or particles, or whatever you want to classify it as. You know what I mean? And that's pretty interesting as well, that the methane or whatever absorbs the light. Not the methane. What was the gas they stated? Let me go back. That's going to bother me. That's going to bother me. It's right here.
Because methane also absorbs infrared light.
Oh, it was methane. I was listening right. Look, my teachers would be so proud of me.
This makes them brighter in infrared wavelengths and makes them visible in the JWST image. You can also see Neptune orbiting a dozen minor moons. Proteus is a little over 400 kilometers in diameter, while most are small and irregularly shaped, measuring under 200 kilometers in width. As you can see, several of them are superimposed on the rings. These are known as shepherd moons because it is suspected that Despina and Galatia's gravity may help to condense the adjacent ring particles into little bands. What about that stunning teal star? Actually, that's Triton mentioned earlier, the biggest moon of Neptune. At 2,700 kilometers wide, it is slightly wider than our own moon at 2,700 kilometers, but larger than Pluto. The lines running through it are diffraction spikes, which are produced when light bends around the three legs holding the secondary mirror of the JWST together, as well as the hexagonal shape of its component mirrors.
Now, that's not to be confused with Titan, correct? I'm asking y'all, right? That's not to be confused with, because as soon as I heard Triton, I was thinking they were referring to Titan. You know what I mean? Because we've been suspecting that there could be life on Titan. So that's what kind of threw me off for a second when I heard that. I was like, huh? Isn't that the one? But I kind of got it confused with Titan.
WST together, as well as the hexagonal shape of its component mirrors. It appears bright because it is covered in frozen nitrogen, which is highly reflective. A larger source, such as Neptune, also has them, but they are smeared out and appear much fainter, making them difficult to see. Only when the light source is very small in an image, what astronomers refer to as a point source, can you get them this obvious, appearing much fainter, making them difficult to see. Triton is an oddball. It orbits Neptune backward in relation to the planet's rotation, leading astronomers to hypothesize that it might be a sizable Kuiper Belt object that was long ago drawn in by the planet's gravity. It's challenging to accomplish this, and the precise method in this instance is unknown. In this up-close view of Neptune, the clouds and rings are more clearly visible along with some of their fainter rings. It's interesting to see that a very thin, faint line circles the planet only around its equator. The circulation in Neptune's atmosphere moves from the poles towards the equator, where the gases sink and warm up, making it very dissimilar to our atmosphere. This weak arc might be warmer gas that is heating up and emitting infrared light. Neptune and Triton may be seen in this breathtaking wide-angle view once more, but this time, practically everything else in the picture is a background galaxy that is hundreds of millions or possibly billions of light years away. It serves as a poetic reminder that Neptune is the solar system's final major colony. Since an orbiter could spend years first at Uranus before moving on to orbit Neptune, scientists are very interested in developing a mission specifically designed to explore the outer planets. Sending a probe that stays on a planet for a long time is the best way to learn about it, as we discovered with Cassini at Saturn. Features come and go, conditions shift, and perhaps most significantly, when researchers uncover novel occurrences, they may direct the spaceship to investigate more closely. While learning new things is crucial, a focused objective allows you to remain and possibly ascertain their origin. We also learned that lesson from the Voyager flybys. Seeing Neptune up close for the first time allowed for discoveries like the dark storms. But if we want to understand them, we need to go there again and again. So are we ever going to Neptune? Obviously not with astronauts, but rather with a spacecraft created exclusively to investigate the mysteries of our 8th planet. The James Webb Space Telescope, the most recent space observatory in existence, is currently watching the ice giant and should produce further, previously unobtainable information about the makeup of its atmosphere. However, it's not the same as actually being in orbit. By that standard, we have no knowledge of Neptune and probably never will. A recent mission plan for an orbiter to Neptune called for an initial launch in 2033 and an arrival in 2049. However, traveling to Uranus first would mean delaying that timescale by at least 10 years. The bluest planet might not get a spacecraft companion until well into the 2050s.
Wow.
Thanks for watching another episode of Voyager. While you're still here, make sure to click that.
I don't know. I think they got a little incentives. You know what I mean? Hearing diamonds in the beginning of the video, man, that I think they got an objective there that they think something of value is there as well. But they got to be sure that they can keep themselves safe if they're ever going to send any type of people to that planet, bro. The temperatures, the storm, all of that type of stuff, man, makes it very, very dangerous. You know, I'd rather them keep sending probes there to study it and send back information as much as possible, you know? But y'all get at me in the comment section, man, and let me know if you learned something or got any new information from Neptune, some a planet we don't get to talk about much. All right? It's your boy L, man. Y'all stick around and stay tuned. Till next one, I'm gone. Peace.